Let's review data warehouses and data lakes and how they differ from each other and when you might choose one over the other. We'll start with data warehouses. This is kind of the legacy approach to data engineering. It is a centralized repository optimized for analysis where data from different sources is stored in a structured format. So structured format being the key here, right? So we already have it well defined in sort of a traditional relational database is what this all means. They are designed for complex queries and analysis. The data is cleaned, transformed, and loaded. So we're using an ETL, extract, transform, and load process to get that data in there. We'll talk about that more shortly. Typically, it's stored in a star or a snowflake schema, and we'll talk about that a little bit more when we go into data modeling. And it is optimized for read-heavy operations. So the data warehouse is just designed to collect a bunch of data, massive amounts of data, maybe from different sources, and organize it in a manner such that it can be efficiently queried for different applications at the end of the day. Some examples of data warehouses for AWS, that's going to be Amazon Redshift is their primary data warehouse offering. And obviously the exam isn't going to ask you about Google BigQuery or Microsoft Azure SQL Data Warehouse, but those are the equivalent technologies on those other platforms that we don't talk about. And back when I worked at Amazon, before Redshift even existed, we used a giant Oracle database for this process, and it was extremely expensive and hard to maintain, I might add. Here's an example of a data warehouse conceptually. Let's imagine that we're Amazon again, and we have a big old data warehouse that ingests information from a bunch of different sources. So maybe we have a repository of clickstream data that's just coming off of our raw server log somewhere and getting pre-processed. Maybe we have purchase data as well, who's actually ordering stuff and what are they buying. And catalog data, what's the actual information about these items that they're buying. So you can imagine that these all refer to each other, right? So the purchase data and clickstream data probably both need to tie into that catalog data to understand what people are clicking on and what they're buying. All that data gets thrown into this big old giant data warehouse, and that data warehouse might have different views made available for different types of queries or different applications. So one size does not fit all. You'll want a different subset of that information and different indices perhaps for different applications and different queries that you might want to do. So maybe accounting has a view on the data warehouse that includes information that other people don't need. People just doing analysis on customer behavior might have yet another view, their own data mart, if you will. And maybe if I want to do machine learning on that information, that also has its own data mart as well, where I can do big extracts of consumer behavior information that I might want to train a machine learning model on, for example, a recommender engine. Now let's contrast that with a data lake as opposed to a data warehouse. A data lake is just a big old storage repository that holds a vast amount of raw data in its native format. That might include structured, semi-structured, and unstructured data. So we're just throwing all that data into one place and we're going to figure it out later is kind of the approach here. So we can store large volumes of raw data without a predefined schema. The data is loaded as is. We do not pre-process it up front. And if we do, it's minimal. This can support batch, real-time, or stream processing and can be queried for data transformation or exploration purposes. So an example would be Amazon S3. When you use that as a data lake, you can just throw all your stuff in there, all of your logs, all the information you have, and then we can extract the structure from that later on using some other tool. So with a data lake, we're just storing the raw data. We're going to figure out the problem of structuring and querying that data later on. In the case of AWS, usually that pipeline looks like using something like AWS Glue to extract a structure and a schema from that unstructured data that's sitting in S3, and then tools such as Amazon Athena and others can use that Glue data catalog to figure out what the structure of that data is and how to query it. But the data itself is always stored in its raw format. We're not replicating that data. We're not putting it into a relational database. It's stored as is in S3. And if we're talking about other competing platforms, Azure Data Lake or HDFS on the Hadoop ecosystem would be alternative places to store your data lake data. Let's compare the two more specifically. So again, on schema, with a data warehouse, it's what we call schema on write. We know what our schema is, what our structure of that data is, before we write it to disk. So when we're processing data warehouse information, we will extract the data from its source, we will transform it into the schema that we know up front, and then we will load it into our database, okay? As opposed to a data lake, which is schema on read. We don't know what that structure is until we go to read that raw data. So with a data lake, instead of ETL, we do ELT, extract, load, transform. We extract the information from its source, We load it into S3 or wherever it's going, and then we transform it later on when we need to. We might have multiple kinds of transformations happening on that raw data for different types of application. But the data itself is stored in its raw format. That's the main difference. Data warehouse is storing structured, transformed data. Data lake is just storing the raw data in its original form. Data warehouses, again, are more appropriate for structured data when you know what you got. Data lakes can handle both structured and unstructured data. So don't care what you throw into S3. It can be anything. It's just an object store, right? Agility. Data warehouses tend to be less flexible because you do have that predefined schema, and sometimes you change your mind on what that schema is. And when you do, that usually involves some big data migration project that involves downtime of the data warehouse and very expensive people to make sure that it goes smoothly. As opposed to a data lake, since we're just taking raw data and we don't really know what the structure is or care up front, you can just keep on throwing more stuff in there and maybe change that schema over time as you go and deal with that at a layer above it all. So it's a little bit more agile that way. Just to reinforce, data warehouses typically use an ETL pipeline where we extract information, transform it, and then load it into the system, into a database in its transformed state, as opposed to data lakes, which use ELT, where we're just loading stuff in its raw form. Or maybe we're just loading stuff in there for storage purposes, and we'll figure out if we want to do stuff with it and analyze it later on. We just want to hoard it away somewhere maybe. That's still a data lake. Data warehouses tend to be more expensive because, well, it takes more people and more expensive tools to do all that transformation and structuring, and we need to optimize that more for complex queries. So a lot more thought needs to go into how that data is organized to ensure quick processing and quick querying later on. Data lakes can be more cost effective. Things like S3 are pretty darn cheap, but if you do have large amounts of data, it can add up fast, of course, as with anything. How do you choose one over the other? So just to recap, use a data warehouse if you have structured data sources, you know what that schema is up front, and you require fast and complex queries. So because you know that schema, you know what indices to build, you know how to optimize those queries up front. Data integration from different sources is essential. So your data warehouse typically ingests data from different sources, otherwise it's just a database. And business intelligence and analytics are the primary use cases of a data warehouse. Data lakes are going to be appropriate when you have a mixture of structured, semi-structured, or unstructured data. Maybe you need something more scalable, more cost-effective because you have a massive amount of this data. And maybe you don't really know what you're going to be doing with this data in the future. I mean, I think that's usually the case, right? So that data lake brings more flexibility in storage and processing down the road. You don't need to go and reload everything just because you want to analyze your data a different way. Data lakes are typically used with advanced analytics, machine learning, and data discovery systems. So very common to have a data lake of raw log data, raw behavior data, whatever it might be, extract that into features for machine learning and train a model, stuff like that. Sometimes you use both, right? So it's okay to have both a data warehouse and a data lake. You might even have the same data in each for different applications, right? So maybe you store the raw data into a data lake and have more flexibility of what you do with it there. But if you want to do, BI stuff and analytics, maybe you also load it into a data warehouse. That's more optimized for those use cases. So it's not a one or the other kind of choice necessarily. It's more about having the right tool for the right job, right? One more option is called the data lakehouse. This is kind of popularized by the Databricks world. Its definition is a hybrid data architecture combining the best of both worlds. So we have the best features of data lakes and data warehouses, trying to provide the performance, reliability, and capabilities of a data warehouse while maintaining the flexibility, scale, and low-cost storage of data lakes. So a data lakehouse also supports both structured and unstructured data. It allows for schema on write and schema on read, provides capabilities for both detailed analytics and machine learning tasks. It is typically built on top of cloud or distributed architectures such as AWS, and it can benefit from things like Delta Lake, which brings ACID transactions to big data. And we'll talk about ACID a little bit more later. That's basically the promises that a database makes and how that data is processed and handled. Some examples. AWS Lake Formation, used together with S3 and Redshift Spectrum, is an example of a data lakehouse where we have a big old blob of data sitting in S3, but we're using Redshift Spectrum to query that just like it's a data warehouse, but the underlying storage is not structured. It's actually hitting S3 under the hood. So it's sort of this hybrid again between a data warehouse and a data lake. This kind of seems to be where the world is heading right now. Delta Lake is built on top of Apache Spark, Databricks, Lakehouse platform, another one, and Azure Synapse Analytics. Not going to talk a lot about those last three because they're not about AWS, and therefore you will not see them on the exam, I don't think. But AWS Lake Formation with S3 and Redshift Spectrum is definitely a use case you want to pay attention to as we go through this course.